In this video, I'm going to take a look at the sum of odd numbers using a visual. So you can see in this first example, we have one small square. In the second figure, we have one small square surrounded by three more small squares. So if we have a total of 1 plus 3 squares. Another way of looking at this is we have two groups of 2. A 2 by 2 square is 2 times 2, or 2 squared, which gives me 4. And we can see this pattern continues. There's 5 here, so that'd be 1 plus 3 plus 5. There's 7 here, so it'd be 1 plus 3 plus 5 plus 7. There's 9 here, so that'd be 1 plus 3 plus 5 plus 7 plus 9, and so on. If we count these up, we see there's 11 on that L shape and 13 on this one. And so that really shows why we could take 1 plus 3 plus 5 as 3 times 3. And here, the odd numbers up to 7 as 4 times 4, 5 times 5, and so on. So just want to point out how it's helpful to see sometimes a picture as a visual and not just as the numbers here. So we have the visual thinking of odd numbers and adding them as squares. I'm going to tell you a quick story about a brilliant mathematician. His name was Carl Gauss. The story goes that when he was 8 years old, his tutor was so tired of him just so quickly getting work done and bothering him and wanting more work, that the tutor finally said, "Carl, add up the numbers from 1 to 100. And a few moments later, Carl said, "It's 5,050. And the tutor was just blown away. And, "Well, how did you do that?" And Carl said, "Well, I just took 1 plus 100, that's 101. I knew that 2 plus 99 was 101. 3 and 98 is 101. 4 and 97 is 101, and so on." And he kept following that pattern and knew that pattern would continue until he got to 50 plus 51, which also gives him 101. So he knew that his final answer would be 50 times 101, or 5,050. This is great. This strategy will work anytime you're adding numbers that are increasing by 1, or even if they're consistently increasing by 2 or 3, you can do the same strategy of pairing numbers together. In this case, it was pretty easy to find this middle number. Sometimes it's a little more challenging to find that middle number. And so I wanted to show you another strategy you can use to solve Carl's problem. And that is to do 2 sets of numbers instead of just 1. If you do 2 sets of numbers, you just flip the second set around. Do you see now I'm adding up the numbers 100 down to 1? And in this case, I'm going to add vertically. I'm going to add these pairs of numbers together all the way through. And what you find is, surprise, surprise, all of these add up to 101. And so in this case, we end up with 100 sets of 101, but we added up 2 sets. So to get 1 set, we have to divide by 2. So the numbers 1 up to 100, that's poor notation there, I'm sorry, will equal 50 times 101, which is 5,050. To get to 50, I just divided that. So another strategy, here we're working with odd numbers that make squares. Here we're just working with consecutive numbers. It doesn't necessarily make a square, but it does have a visual representation. I'm not going to draw it out to 100, but you can see I've just done it for the sum of numbers 1 to 5. So if we use Carl's method that he used here, and we think of adding up 5 plus 4 plus 3 plus 2 plus 1, you can think of this as adding in the numbers. Sorry, that didn't work like I had thought it would. Here we go. That's what's going on. Okay, so if we add up the picture here, you can see we end up with 1 green square here, 2 green squares here, 3 here, 4 in that row, and 5 in this last row. And so instead of trying to add all the time, we can do some multiplication. We see we have one group of 6 here, one group of 6 here, a group of 6, a group of 6, and a group of 6. So we end up with 5 groups of 6. So we know there's a total of 30, but since we doubled it, we can just take half to get just the green or just the purple. So we know that 1 plus 2 plus 3 plus 4 plus 5 is half of 5 times 6, which gives us 15.